Okay, good afternoon to everybody. Today we'll discuss about the complex function, complex variable of a function. Okay. First of all, what is neighborhood of a point? Neighborhood of a point or a region. Then we can define the other one. Suppose we have a disk or ball like this, and the center. This is the center, and this is the radius r. There are many points. Suppose z1, z2, z3 dot dot. There are many points here, and here z naught is the center. Remember it. So the radius of the equation of this circle will be what? Modulus of z equals to r. You must know modulus equals to what? X square plus y square root over equals to r. Therefore, the equation of circle what will be? X square plus y square equals to r square. That means 0 0 is the center, 0 0, and radius will be r. So what will be the neighborhood of the point? Uh, the interior of the point, the set of all points of the complex plane inside the circle. All our points will be the inside the circle. By a neighborhood of a point, by a neighborhood of a point z naught. Z naught is the center in the complex plane. This is the complex plane. Complex plane. The complex plane inside the, we mean the set of all points of the complex plane inside the circle with center z naught. The center will be z naught. That is the interior of the circle. That is the interior of the circle. All the points z1, z2 dot dot, all points of this interior of the circle. Circle equation what will be? That means z minus z naught equals to r. Okay, this is the distance between all points of z1, distance between z naught and z1, z1 minus z naught, z2 minus z naught, z3 minus z naught. That means all distance will lies inside the circle. Okay, because all distance less than r. The interior of an open circular disc. The interior of an open circular disc. It look like CD. Okay, disc. All the interior points will be the neighbor. So add del neighborhood of z naught. So del neighborhood of z naught is the open circular, open circular disk, open circular disk. Which one? Z minus Z naught less than del. Then radius will be del. If del, then del neighborhood, and if R neighborhood. Okay. So the radius will become what? Del. That now what will be the deleted neighborhood? A deleted del neighborhood of Z naught is will be what? Center 0 0 will be deleted. Okay, origin will be deleted. Then Z minus Z naught less than R. Sorry, del. This will be del, and this will be denoted by del neighborhood, deleted neighborhood, and this is del neighborhood. So this is the actually definition of neighborhood of a point Z naught in a complex plane. Now, what's the limit of a function? Let f of z be any, let f be any function, complex function in a complex plane. So let f be a function defined in the some neighborhood of z naught. Okay, except possibly at z naught. Then we say a complex number w naught is the limit of this function f of z as z tends to z naught for any del greater than 0, which is very small. Del greater than 0, which is very small, that will be exist epsilon greater than 0 such that f of z minus w naught less than epsilon whenever z minus z naught less than del. That means we can draw a figure like this. Suppose for the z plane, suppose this is the z plane for domain of the complex number, complex variable, and this is the w plane. Suppose we can draw, this is the real axis, this is the real axis, and this is the imaginary axis. Remember it. If we draw any neighborhood with center z naught, this will be del. Okay, center will be what? Z naught. So radius will be what? Del. So there are many points, z1, z2, z3 dot dot, many points. So this is the input. Okay, for this input, image will be what? Image, there will be another, for every z we get f of z. Okay, so the center will be what? W naught. Okay, we get another circle with epsilon radius. Okay, so the neighborhood of this will be inside the circle. Okay, and this is the actually function f of z function. Okay, this is the input variable z, and we get the output here. So the definition, according to the definition of limits, for every z we get f of z. This is the actually f of z. So, suppose for z1 we get f of z1, for z2 we get f of z2, for z3 we get f of z3. So we get another small neighborhood for every neighborhood. That means if the functional difference means what? F of z1 minus center means what? W naught. So f of z2 minus w1, every distance, functional difference will be less than epsilon if this condition is satisfied. Point difference means what? Z naught, z minus z naught. Z means what? Z1, z2, z3, many points. So there are many points for values of z, and the distance will be less than del, small circle, which is very small. Del is very small. Okay, then we get this functional difference which is less than epsilon. epsilon is also very small. Okay, the functional difference will exist whenever this satisfied. Point difference will be less than del. This is the actually uh, del definition of limit of a function. Remember it, complex function. Limit of a complex function. So symbolically we can write limit z tends to z naught. If z tends to z naught, then the value of f of z will be tends to w naught. Very near, not equal, but very near to w naught. So actually for every z, there are many z. This point, suppose this point, for every values of z, we get f of z here. F of z. Okay. And this is the mapping. This is also called mapping or transformation. Okay. Transformation to what? From z plane to w plane. And here real axis will be what? X and y. And here real axis will be what? U. And imaginary axis will be what? B. Remember it. W can be written as U plus IB. But in z plane, z equals to can be written as x plus IY. Here x is variable and y is also variable. X is x will be real axis variable and y will be imaginary axis variable. But in W plane, U will be what? U will be real axis variable and V will be imaginary axis variable. Then we get the mapping. Okay. This is the complete definition of a limit. Now we will try to define the continuity of a function. What will be the continuity of a function? Continuity of a function. Continuity of a function of a complex variable. Let f be a function defined on a neighborhood z naught defined on some neighborhood z naught, including same definition. This will be same definition. Same function f of z. F of z will be same function f of z function defined in the same some neighborhood of z naught, including z naught. Here we have to remember that the center will be including z naught. The center will be including for the continuous. Then f is f of z, function of complex variable, is said to be continuous at z naught if the limit exists. If the previous definition exists, that means limit z tends to z naught f of z will be exist, and this limit will be equal to the value at functional value at z naught. Okay, this value, if the limit and the functional value at z naught will be equal, then we can say that the function f of z will be continuous at z naught. Okay, this is the complete definition. That means limit will be exist and the value of limits will be functional value at z naught. So this is the complete definition of continuity. So now what will be the definition of derivatives? Okay, now derivatives of a complex function of complex variable. So what will be the derivatives of function of complex variable? Let f be a function defined in a neighborhood z naught, then the derivative of f at z naught can be defined as the ratio functional difference divided by point difference, and if we get the limit of that ratio, then it will give the actually derivatives of f of z at z naught. Suppose this is the function of complex plane, z plane. This is the x is real axis and this is the imaginary axis. So suppose this is the z plane, and any curve we can draw like this. Suppose this is the and this is the x, and here this will be length y, then we get a point P. Suppose there is a curve. This is the f of z. This is the f of z curve. Sorry, we can write this to get a. Suppose this is the f of z curve. F of z curve. So we can draw any tangent in every point. Actually, tangent equals to what? Functional difference divided by point difference. Okay, functional difference divided by point difference. Suppose this is the z plane. Point difference will be if we draw a small neighborhood. Suppose this is the z plane, and for this z plane we can write this perpendicular divided by base, and base will be, suppose we can draw a tangent like this. This is the tangent. Okay, this is the tangent. For this tangent we get f of z values, right? This is the f of z values, and this will be only z values. So this is the z naught. Okay, this is the z naught, and suppose this is the p and this is the m. So OM equals to what? OM equals to what will be OM? This is the base. Base will be z minus z naught. Okay, and PM equals to what will be PM? PM equals to what will be? This is the f of z distance. F of z minus f of z naught. This is the f of z naught points. So if we take the limit, tan theta equals to what will be? Tan theta, or slope of this curve. Tan theta equals to what will be? Perpendicular by what? Base. But perpendicular means what? F of z minus f of z naught divided by what will be? Base. Base means what? OM. Z minus z naught. So if we take the limit of this ratio, that means this will give the differentiation of z, or dz divided by differentiation of f with respect to z will be this z naught. If z tends to z naught, then the ratio of functional difference what? F of z minus f of z naught, that means perpendicular. Okay, perpendicular divided by base, point difference or equal to base will be given by the derivatives of f of z. So what is transformation or mapping? Let a function is continuous or analytic function. In our next class we will know about what is analytic function. Let a function is continuous at everywhere except z naught in the z plane or xy plane. Z plane or xy plane, same words, and the plane in which the corresponding to w equals to f of z, and this equals to u plus ib. That means w plane or ub plane, same words. Then if z maps to w, and z will be input and w will be what? Output. That means image will be image of the function in function will be what? W. That means z variable what? X comma y, and w variable what? ub. Xy transform to what? Ub, or equivalently u will be the function of xy and b also function of xy. Then those equations defines as the transformation or mapping from z plane to w plane. Okay, that means this will be the mapping from what? Z plane to w plane, f of z. W equals to what will be? F of z. So this will be the mapping or transformation, and this is the z plane and this will be the w plane. And z plane, real axis what? X variable, and imaginary axis will be y variable, and here u, and imaginary axis will be b. So the z plane in terms of xy and w plane will be in terms of ub. So if xy trans transform to ub, then this will be called transformation or mapping or function. Same words. Now we will define very important definition. Important definition means what? Conformal mapping or conformal transformation. We'll try to define it. This is also one kind of mapping or transformation, but when it will become conformal. Okay. When it will become conformal. A mapping that preserves the angle, a mapping that preserves the angles between any oriented curve, between any oriented curve, both in magnitudes, and sans is called conformal transformation or mapping. That means if these two angles will be equal like this, suppose I am drawing again. Suppose in W plane we have like this, and this is the W plane, this is the Z plane or XY plane, and this is the W plane or UB plane, remember it. Okay, UB plane, and we have suppose a curve like this and a curve like this. Okay, similarly we get another curve here. Suppose this is the curve and this is the curve. Suppose this is the C1, curve C1 and curve C2, and this will be Z0, suppose Z0, and this will be angle what? Theta. Okay, suppose for the C1 curve the image will be C1 dash. Okay, and for C2 curve C2 dash, the angle between will be what? Suppose pi. Okay, pi. Okay, and here angle what? Theta, and intersection point will be given by W0, and this will be Z0. So from the figure we observe that This is the origin. Okay, we observe that the two angles theta and phi have same magnitudes. Theta equals to pi. Okay, if theta equals to pi and give the same sense, that means equal figure, then it will call what? Conformal transformation or mapping. That is, theta and pi have the same value or magnitudes. Magnitude and sense. That means similar to C. Okay, have the same magnitudes, same magnitude and sense. Is called what? Is called conformal transformation or mapping. Conformal transformation or mapping. Suppose this is the direction, that means the angle direction what? C1 to C2. Okay, and this also C1 to dash to C2 dash. That means direction same and magnitude same. This is why we can say this will be conformal. Now, what will be non-conformal transformation? That means which is not have, suppose we have the same magnitudes, but the direction not same. Suppose direction will be like this, then it will not conformal transformation, although it has same magnitudes. Okay, same value, but the direction is not same. This is why these types of transformation will not call what? Conformal transformation or conformal mapping. This is not conformal mapping because the direction are not same. Okay, this is why this is the example of non-conformal mapping or direction, because theta and pi have the same magnitude but not opposite sense. That means direction. Understand, everybody?
Yes, sir.
Z plus 2 plus I. That means the first example of transformation. This is the example of transformation. Transform the rectangular region ABCD in Z plane by x equals to 1, x equals to 3, and y equals to 0 and y equals to 3. That means this is the value of Z plane under the transformation W equals to Z plus 2 plus I. So for the solution of this, we are given what? Given Z equals, sorry, W equals to what will be? Z plus 2 plus I. But Z equals to what? X plus IY. And W equals to what will be? U plus IB. U plus IB plus 2 plus I. This can be written as X plus 2 real part and I will be common, Y plus 1. Okay. Now equating the real and imaginary part by equating real and imaginary part, we have what? U equals to what will be? X plus 2 and B equals to what will be? Y plus 1. This is the first example for you. Now we can draw a box for the plane, both plane. Suppose this is the Z plane values, and this will be the W plane. This will be the W plane. And another Z plane, then W plane. So here we get input X, and you depend on X. Here input would be Y, and B will depend on Y. So X value what? 1, and other is what? 3. And Y value what? 0 and 3. Now if U equals to what was? U equals to X plus 2, and B equals to what? Y plus 1. Now if X equals to 1, then U equals to what? 3. Now if X equals to 3, then U equals to what will be? 5. Now if Y equals to 0, B equals to what will be? 1. And if Y equals to 3, then B equals to what will be? 4. Understand everybody?
Yes, sir.
Yes,
Sir,
sir.
hello, sir.
So here we get the lines of Z plane: X equals to 1, X equals to 3, Y equals to 0, and Y equals to 3. This is given here. Is transformed 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 to what? Uh, this is the value of Z plane. In Z plane, transformed to the line formed onto the line. U equals to what? 3, U equals to 5, and B equals to 1, B equals to what? 4. In the W plane. In the W plane. So the region ABCD in jet plane, suppose if you draw the figure, we can draw figure. Suppose this is the Z plane. X equals to what? 1, 2, 3. And Y equals to what? 0, 1, 2, 3. Suppose X equals to 1 what? X equals to 1 here. So this is the equation which parallel to Y axis. And X equals to 3 will be equation parallel to what? Y axis. Now if Y equals to 0, this is the what? The line equation of X axis. Y equals to 0. This is Y equals to 0. Remember it. And Y equals to 3 will be this. This is Y equals to 3. This equals to what? X equals to 3. This X equals to 1 line. So we get a region ABCD. This is the A, B, C, D. ABCD region. Okay. And this will be in jet plane. Okay. Now for W plane, this is the U value, and this will be B value. U equals to what? 1, 2, 3, 4, 5, 6. Suppose and B equals to 1, 2, 3, 4. Higher value. Now if U equals to 3, 1 2 3. This is the then parallel to b axis, parallel to imaginary axis in w plane. Now another one, if this will be what, u equals 3. Now u equals to 5, what will be this? This equals to u equal to 5. That means parallel to b axis. Now another b equals to 1. This one. B equals to 1 means what? Parallel to u axis. This this equals to what? B equals to 1. Now b equals to 4, what will be 1 2 3 4? This one. This b equals to what? 4. 4 below 1 below. So this is the another transformed region of ABCD. Okay. This is the image. This is the image. This is the image of this. What will be? E F Z H. So we get another transformed region. What? This is the image in W plane. This is the figure 1 and this is the figure 2, W plane. So from the table, just putting the values in the figure, we get ABCD region for the input, that means for the Z plane, and for the Z plane, we get the W plane, just putting the value of U and B in the second figure, that means EFGS. That means this is the input region and this is the output region. Okay, this is the domain, this is the range. So there is a mapping with this. That means Z transform to W. That means Z plane transform to W plane by EFGS. So this is the actually result, and we can say the region, hence the region ABCD, hence the region ABCD in jet plane, in jet plane, in jet plane transform to transformed onto the region, the region EFGH in W plane. Okay, this is the figure. And this is the first problem for the transformation or mapping, and this is the very easy example for you. Very easy example.